we want to, last time we looked at the introduction to electronics and why it is important to learn it as an innovator, as a scientist, and also in your career in robotics, in mechatronic systems, and then also doing it to help you repair your household equipment, also as a hobby. And then we introduced electricity because we'll be using electronics. Basically, it's just the study of electrical current and the devices, how they control it. So we learned about current, voltage, and conductors, non-conductors. And then we introduced to resistors, switches, buttons, all this. So we want to today introduce you to what is called the Arduino. How to, we are not installing it, but we are going to use a simulator. We are going to install it when we get the actual hardware and continue. So, I'll be using draw.io to illustrate some few things here. Just a minute. Okay. So there is the area of mechatronics, in short. So mechatronics. So mechatronics itself, from the word mechatronics, we have two things. We have mechanical, isn't it?
Yeah.
Yeah. We have mechanical. So we are going to have mechanical systems. And then we have electrical or electronic systems. So here we have electronics. Okay. And actually, it's not only electronics alone, because we also have got what is called computer science.
Yeah.
Okay. Or computer science, or let me put it down here. So we have computer science. So it is having three disciplines which are related. So the mechatronics will deal, the mechanical part will deal with the if it is a robot or if it is an equipment, the physical mechanical systems, which means things like motors. So here you are going to deal with things like for example, the metal parts, or the moving parts. We are talking about the casing. We are going to talk about gears, and then gears also has got what is called gearbox, which is controlling the motion. All mechanical parts of the robot or of the system that you are building. If it is an aircraft, think of it like if it's an aircraft, you are talking about the engine, and we are talking about the wings. We are talking about what's called the fuselage, the outside. So those are mechanical parts. Then electronics or electrical part, we are having motors, and there are different types of motors. We are having what is called speed controllers. So speed controllers are some electronic components which we are going to learn about. We are having something called encoders. Encoders. So encoders, they help in measuring the speed of a motor which is rotating. We also have the PCB. So this PCB or the electronics inside this PCB can consist of many other things. Power, like the power supply, how you are connecting the power. Is it a battery? Is it electricity, mains electricity? We are having sensors. Sensors, like for example, if it is something which is working under light, we can have the light. We can have sound sensor. We can have temperature. So many sensors are there. So those sensors will be part of the electronics. And then also there is also what is called communication modules. So they can communicate via Bluetooth. They can Bluetooth. They can communicate, or the communication module, I can as well say it is wired, which has wires, or wireless. Okay? Are we together?
Yes, yes.
Yes, the communication system can be wired or wireless. So those are part of, there are so many things that are consisting of the electronics here. So we will take use an example of a robot, and then we look at what makes up the electronic components, what makes up the mechanical components, what makes up the computer science or the computing. Let's just say computing system. So under the computing, we have got the operating system, OS. For example, OS can be Windows. So you can make a robot that uses the OS. We can have what is called the drivers. So for example, if you are using a camera, the camera has drivers. Then we have got something called firmware. Firmware and drivers are slightly related, but it's according to how you are using it. Like drivers are found on a computer like Windows, but firmware is used in things which have low memory. Like for example, if you look at a heart pacemaker, or if you look at something like a Nest thermostat, things which are used in the house, like a TV, they have got some software which is running in some devices, some of those devices, which is called firmware. So that is what we will be doing a little bit. And then there is also something, so drivers, firmware, they are software which somebody installs. And then we also have applications. So there are also some applications which you install. For example, if you have got a device to monitor your home, then you will need to have some application installed onto that device for camera, for doing all those things. So it is this, and it can include other new fields. Traditionally, these were the most useful ones, but now, have you heard of something called AI? Hello? Hello? Yes, so AI, or artificial intelligence, is also a new way to include a new thing. So it has got what is called algorithms. It's just how to, if you want to build something like a robot which can walk on its own, or a human and robot that can move along its own. So there is some special algorithm which you can put, or which you can write, which you can develop. Basically, you are telling it how to walk around, or where to go to, and do all. If it sees maybe a human being, what should it do? Things like that. So those are what is called algorithms. So algorithms is also part of it. So now the concept is it's multidisciplinary. It is not just one one discipline. It has got many disciplines put together. Okay. Can you be able to see that? Yeah. It has
Yes, yes.
yes, many disciplines put together. So,
Mm.
so this is at, I can say, at high level. Okay, or at look at, if you look at mechatronics at a high level, this is what it's all about in brief. But for you to be practical or for you to do something, then you need to know the software, some of the software and the applications that are used to do these things. Okay, so from this level, you have to look at some of the applications that are used. So if we start with the mechanical engineering, mechanical part, then there is what is called CAD software. Can you see that? CAD software. Okay, for as a mechanical engineer, you are going to learn so many concepts in if you are taking mechanical engineering. But one key thing that you also need to know is what is called CAD software. So some of the most popular CAD software which is used is what is called SolidWorks. Okay. Can you see that? Yes, there is Fusion 360, SolidWorks, Fusion 360, and then there is also one which is called Inventor. Okay, Inventor. There are so many that you can get to use. So they are used to design something in 3D. So let me just show you in brief. SolidWorks. Can you be able to see my diagram, my screen? Can you see?
Yes, yes, yeah, I can see, yes, I can see a
Yes,
screen.
yes. So SolidWorks is a very popular software used in the industry. And you know, like now this person is designing a robot, okay? Or is designing a bike, okay? Or is designing an engine of a car, okay? Or an engine of a block of engine. So many things. Okay. So the design of this outer, the mechanical part, the mechanical part are this belt, there is the casing, the metal casing, there is some motors here, then there are gears and all that. So you design it using SolidWorks. Can you be able to see that?
Yes, yes.
Yes. There is Fusion. There's another one called Creo. There are so many. And the one that I would want you to think of, just use SolidWorks or Fusion 360. Are we together? Yeah?
Yeah.
Yes. And then when you come to electronics, electronics also has got its own electrical CAD software. So this one, we will call it MCAD. MCAD, okay? Where M there stands for mechanical. Are we together?
Yes, yeah.
Yes. Then here, electrical also has got E-card, electrical card. So when you join college, you will be able to use some of this. One is Altium, it's very popular. Another one is called Cadence, or what is called Allegro. And then we also have a popular one which is called KiCad. KiCad. And then there is also even Fusion 360. Fusion 360 can be able to do all that. Electrical. It can do both electrical and mechanical. They put them together when they bought this, when the company bought it. So they are working together. Okay?
Sound.
So that is one. So I'll look for the KiCad. We will look at KiCad, or I would recommend that you start by learning KiCad, and here you start by learning SolidWorks or Fusion 360. So whichever one you would want to learn. As an electronics engineer, you can start with learning this. And then this other one, computing, this other one we looked at. Do you remember the languages we said you can use? Remember Python, which we learned, isn't it?
Python.
Then,
Yes.
then C
Yes.
or
C,
C
C
plus plus
plus.
plus. And then there are also other funny languages that people are using, like other people are using Node.js of JavaScript. It's not the very best, but it will work to do other things. There are also other people who are using. There is a language. There are so many languages. Bash or shell script, something like that. Can you be able to see that? Yeah.
Ah.
Yes, and then the OS, the operating system, which is common for building these robots. There are so many. You can use Windows, but they normally use Linux. It's very common. Then, but also you can also use Windows. Okay, those are very common. But Linux is very common, and doing that. So this is like if you want to make a robot system or you want to make a mechatronic system, at least you will have to learn a few things here and there from the operating system in the computing. AI, there are things like algorithms. Okay. Then you will also have to learn something called OpenCV. OpenCV. You will also learn something called ROS, Robot Operating System. Okay. Robot OS, robot operating systems. So they work together with AI in that you build something that can use cameras, things like that. Okay? Okay. All right. Yeah.
Yeah.
So we learned about Python. We learned about Python, but today here now we are going to learn a little bit about C++ and something called Arduino. So we are going to learn about C++, just introduction, C++, and then something called Arduino. And then this is the language which we are going to use to program an electronic board. So there's an electronic board. So we have an electronic board which is called Arduino, or for now here we are going to use Raspberry Pico. Pico is a board. Okay. So you connect, you write the software in Raspberry, in Arduino, in the Arduino language. Arduino and C++, they are related. Okay. So you write it in Arduino, and then you have Raspberry Pico, and then you connect things like a motor, here. You connect something like a motor. You have something like a motor. Okay. Here we are having a motor. Okay. So the motor here, you want to control the motor. Okay. So we have a motor here and we want to control it. So you connect it to the Raspberry Pico, which is a board. So the Raspberry Pico looks like this. We use, do you see this? Can you see? Can you able to see it?
Yes, yes, I can.
Yes. So we are going to connect Raspberry Pico and you want to connect maybe a motor. So there are different types of motor. We have bipolar, stepper motor. So like this. So there is a motor here and then we connect it together. You connect it together with a Raspberry Pico. And then before you connect it, there is something called motor controller. What do you think a motor controller does? Um, just the name, motor controller. What do you think it does?
I don't know.
It controls the motor, okay?
Yeah.
So you control the motor in that you want to control the speed. Motor controller. So you may want to control the speed or the direction, how it is rotating. So here, so we have the speed. You may want to control the speed. You may want it to stop. You stop or start. Okay. Then you may want to control the direction, whether it is rotating clockwise or anti-clockwise, things like that. Okay. Are we together? Are we together?
Yes.
Yes. So the motor controller is used there. You understand? I wanted to draw a line in between here. So there is a line, an arrow. So there is these things, I'm connecting them together with an arrow, things like that. Yeah. So this one is connected here, this one is connected there, like that. Okay. So you write in C++ on your computer and you control this thing called Raspberry Pico, and then it works through a motor controller to control a motor. But then there is also something called sensors. I'm going to just use this. There's something also which is called sensors. Okay. So here we have sensors. So for example, if you want to connect if you want to connect something like you want to connect something like temperature sensor. So you want that if there is some heat, like if there is some heat here, then the motor, like a fan, to start rotating. Are we together? If you have some heat, you can connect a temperature sensor. For example, the room, you can connect a temperature or even humidity sensor. And then when the temperature is so high, then the Raspberry Pico will tell the motor control to control the speed of the motor. Are we together?
Yeah.
Yes, yes. So that is the use of the temperature sensor. So the most important thing, we have got what is called the sensors here, and then we have got what is called actuators. So there are two things here. We have the sensors. Sensors are like this temperature sensor, humidity sensor, all so many sensors, gas sensor. And then once these sensors, they work to measure the quantity that they are looking at. So from the sensors, then we have what is called actuators. So the actuators are the motors There are also other actuators that we can learn, relays. There are so many actuators that we can learn. Okay, so we are going to learn a few about a few sensors and then the motors. Like for example, in this case, if we have a light sensor, or let's look for temp. Can you see this?
Yes, yes.
ATC. This is a temperature sensor.
Ultra sensor.
Yes, it's a temperature sensor. You can be able to connect it to this thing and then it will read the temperature. So maybe if the temperature is low or maybe if the temperature is high, I will put
You'll
it
be able
there.
to read that from the computer.
Yes, you'll be able to read it from the computer. And then,
The Raspberry Pico.
yes, on the Raspberry Pico. And then from the Raspberry Pico, you should always have a speed controller here. And then you will be able to, let me just put it here. You'll be able to use it to control the motor. Are we together? That's easy, isn't it? To understand. Yes. So basically, this is what we need to learn in brief. We need to learn about, we already learned Python, then we are going to learn C++, and then the C++, we work, it works together with something called Arduino, which is a software. And then after you've written the software, then you bring it, it works on the Raspberry Pico. There are so many boards which can replace this Raspberry Pico, and you can use whichever one which you have. And then it is used to control things like motor controller, to finally control a motor. Then to make it work, then you may need sensors. There's so many types of sensors, like temperature and humidity sensor. And then you will read it here, and then you write the logic. So this Arduino or C++ is used to write the logic. For example, okay, we can say that if, think, do you remember we learned about if statements? Hmm? Do you
Yes.
remember? Yes. So we can say that if the temperature, so if the temperature is above 50, okay, the room temperature is that normally 37. So let me say if the temperature is above 40, something like that. Do you see that? I'll make it bigger. Can you see it? If the temperature is above 40, can you see? Then we start the fan. Start fan, like the fan which we are operating. Okay. Okay. Can you see that? If the temperature,
Yeah.
if
Can
the
see
temp,
it.
yes, if the temperature is above 40 degrees Celsius, the temperature here, we are having the setup here. We measure the temperature and then we display it here. If the temperature is above 40 degrees here, then we start the fan. Can you be able to see that? Okay. Okay.
Yes.
And then the opposite,
Yeah.
remember we learned about if and else. So if that, then else, if the temperature is below, we stop the fan.
One.
Yes. So if it is, if the temp, if the temperature, if the temperature is above 40 degrees, we start the fan. So the fan, the motor here will rotate and then the fan will work. But if it is else, or else if it is below, you can even say that else if the temperature, temp If the temperature is below 40, then we do what? We stop the fan. Are we together?
Yeah.
Yes. So this is the where we write the software. This is the Arduino C++. Once we learn how to write the software, then you write it to the Pico, and then the Pico controls the motor. Okay. Okay. Is that okay? Yeah. So
So,
yeah. So we have like how many minutes remaining? 7 minutes. Okay, let's continue. Continue. So that is how basically it works in short. So let's now go to our walkway. Do you have walkway? Do you have walkway? Have you opened it? Have you opened it?
not yet.
Okay, open it. And then I want you to start by adding, we added these three buttons, these three LEDs. I want us to now go through the interface. And then when we come back, we start writing the program for Arduino here. Okay? Okay?
Yeah. Okay. Yeah. Anyway, my mic is it's
Mm.
not as loud.
Okay. So inside here, we looked at it. This is where you write the software. This is where you write the Arduino program. This is where you write the C++ code. We are going to get the basics of what it is all about. And then we have got something which is called diagram.json. Here you don't need to change anything. It is telling you the devices which you have put here. This is generated by the computer or by the software. You don't need to change. Don't change anything here. Okay? Are you together?
Yeah. Yeah.
Yeah. Okay, then library manager.
Okay.
Mm. So here don't change anything.
I didn't.
Library, yes?
But I didn't written anything.
Okay, no problem. So when you write something here, then it will automatically generate this. Don't change it. Then
Oh,
library,
oh,
mm,
it's in. Okay. Okay. Nimepata. Okay. Yeah.
yeah. Then in library manager, you are going to have some. You can install libraries. So libraries are to make your work easier. For example, normally you can search for, let us say for LCD. Can you see LCD? Okay. Like if you want to use I2C LCD, then you do like that. You add, maybe we want to look for light. We have a light sensor. Light is not there. We have a temperature. If you want to work with the temperature sensor, do you see this temperature sensor? Can you see?
Yeah.
Yeah, so you add the
Yes.
temperature.
Yes.
Yeah, so you add the sensors because with those sensors, with those libraries, then you can now use it in the here. Are we together?
Yeah.
Right? Yeah, so these are the sensors which you can add sensors like that. Then the rest are we know you know how to do the simulation, you know how to add. I've told you you can click here. So LCD is like this is an LCD. So LCD is a screen. Okay. So that is how to add. I'm not adding it now. You can add what is called seven segment. There are so many things here. There's so many things here which you can temperature DHT. This one is another module. And then here, that one tells you how to do and do all those full screen. Okay. Then you go to have full screen. and then you exit full screen. Then here is to run the simulation, and then you can share. Can you see here? Share. Can you see?
Yes, yes.
Yeah, you can share and then you copy the URL link and then you share with somebody. You can save your work. You can also download it as a zip, and then here you can change the name of the project and then documentation. If you are stuck, like for example, if you want to do blink an LED, can you see this? Can you see this?
Yes, I
Yeah.
can.
So
Yes.
we want to blink this LED. So you click there. Can you see the LED blinking?
Yes.
Yes?
Yes, yes.
Yes, yes. So that is what we can be able to do like that. Okay? Yeah. So let's stop there. We are going to resume shortly and then we will continue from there. Okay? After 10 minutes. Okay?